Welcome to the Cosmos tutorial about LXR binding prediction. The binding to LXR has been identified among the initiating events that may lead to liver steatosis. Within the Cosmos project, we have developed LXR models for the prediction of LXR binding potential. This model can be useful to screen chemicals that are potential LXR binders and thus can be used to prioritize those of potential concern for liver toxicity, as well as provide the basis for grouping chemicals that may share the same initiating event, in this case the binding to LXR. Two LXR classification models based on partial least square discriminant analysis classification methods were developed within the Cosmos project for LXR binding potential. These LXR models are based on two sets of molecular descriptors that are PADL and RDK descriptors. The LXR models were developed and validated according to the OECD principles for LXR validation. And the applicability domain was defined by using two different methodologies that are the leverage approach and similarity approach in order to assess the reliability of prediction. To allow for model reproducibility and free applicability, they were implemented as KNIME workflow that can be executed in the KNIME analytic platform, and you can see here a picture of the workflow, as well as through the KNIME web portal. To execute the workflow in the web portal, you have to enter the Cosmos KNIME web portal page and log in. To log in the Cosmos KNIME web portal, you have of course to be registered, and there is a link below that explains how to register. Once you have logged in with your credential, you will find the public folder. So look for your workflow on LXR binding potential. As you can see here, these are the two workflow implemented, the two LXR models, one based on PADL descriptor and the other one based on RDK descriptors. In this tutorial, I will show you how to run the model based on PADL descriptors, but these are exactly the same. So select the workflow of your interest. In the first page, you will find a summary description of the workflow and an explanation and the input files. In particular, you can input your target compound by drawing it or input more chemicals in batch using a CSV file with mice or input an SDF file. If you're using a CSV file, pay attention to use this specific format. So you have to include just two columns, including molecule name and SMILES, and use these separated by comma and use these specific column headers. To run the workflow, just click on Start. Okay, you are asked the type of the input format. So you can draw a molecule, read a CSV file, or read SDF file. In this case, we will draw a molecule. So click on Next. Draw your molecule here. We'll do just a simple example. And then click on Next. This is the output page where you will find a preview of the final report, including the prediction for your target chemical, so molecule name, the structure of the chemical compound of the target compound, and the prediction. In this case can be active or inactive, where active is potential LXR binder or inactive not binders. Then you will find the values for the descriptor calculated for your target compound and the information on the applicability domain. You can download this report in different formats, such as PDF. You can also input your chemicals in batch by, for example, reading a CSV file. Click on Next. Select the CSV file, click on Next again. Now the workflow is executing. And here again you will find the PDF, the preview of the report, including the prediction that you got for the target chemicals, so as active or inactive. Again, you can download the report as PDF file, and you can download the QSAR prediction and information on applicability domain. You find also here a link to the Cosmos page, where you will find all the documentation related to the QSAR models, including model development and performances, as well as user guides on how to execute the workflow in the NIME Analytics platform and in the web portal. Thank you for watching.